All right, let's talk about 7.16 input-output tables for function rules. Okay, we have been talking about these, let me get a different color, these things, these functions. And remember, the rule that we kind of learned so far was that two inputs, or every time you put a number in, it has to have the same number. Every time you put an input, the same number comes out. So if 1 goes in and then 7 comes out, and we put 1 in again, 7 has to come out. This would be a function. Something happens in there for this function to happen. But if we put 1 in and we get 12, we put 1 in and we get 37, this is not a function. In this case, we could even figure out the rule, at least what appears to be the rule. Even if I put in a couple more numbers into this machine, this kind of arrow creating thing, say I put 3 in and out comes 9. And say I put 10 in and out comes 16. Well, now we can start to notice, we can even develop a rule for what this function is. We can say that whatever number I put in, and whenever I say whatever number, sometimes I can just put x, because that's kind of our variable that represents this. I can say it's going to be plus 6, and that's going to be whatever comes out, equals, we sometimes say y. And then in this case, x is our input, and y is our output. And this is what is going to be the focus of our writing today. Now, when you see them, I want to check and see how they write the homework. They're not going to put equals y always, but occasionally you will start to see this. Now, later when we get into more and higher math, we'll definitely start to see these things. Now, what I kind of created up here, we can actually call an input-output table. And it's going to make it look a little nicer when we actually turn it into a table. So let's take a look at what that might look like. Input, output. And I'm going to use just my little spots within these two things. And what I can see is I can put a number in if I have a rule. So let's say my rule in this case is 3 times a number, or we could say 3 times a number. And really that means 3x. If I put in, and then I can chart some possible numbers. Lots of times I like to start at 0 and just kind of work my way up. Okay, if I put 0 into my function, 3 times 0 is 0. Okay, I'm going to put 1 in. 3 times 1 is 3. I'm going to put 2 in. 2 times 3 is 6. I'm going to put 3 in. 3 times 3 is 9. I'm going to put 4 in. 4 times 3 is 12, and I'm going to put 5 in. That's going to complete my table, and 5 times 3 is 15. Now I have my complete table, and I'm able to say that I'm done. Yay! In this section, you're going to be working with these tables. It's going to ask you some questions. Let me make sure that I've covered everything that it's going to ask you about. You're going to need to create rules to fill out a table. They're also going to ask you to fill in missing numbers. For example, if you were given a table like this with an output missing, you can work backwards. So say I didn't know that this 6 was going to be a 6, and I could say, oh, I don't know what the output is. Oh, wait, no. I meant if I knew this was going to be a 6. Say I didn't know this 3 was going to be a 3. And I say, well, this is end up as a 9, and I know 3 times some number is 9, so then I can work backwards as well and discover that this should be a 3. These are pretty easy, but they're going to lead us into our next stage, which is taking these functions and turning them into graphs. The other thing they're going to start asking you is, are these functions yes or no? And the big way to check this is, does this match the rule that they created? Let's take a look at an example. Let me find one that I like. Give me 1 second. Let's see. So we're really just checking the rule. So let's see if this works. We'll maybe even do one from the assignment. And say it says the rule is 4x. And they give us our table like this: input, output. And it might say 0, 1, 2, 3, 4. And our output might say 0, 4, 9, 12, 16. And we might have to check each of these numbers. 0 times 4 is indeed 4. 1 times 4 is 4. 2 times 4 is 8. It's not 9. So this table is a no. It does not work, and it is not correct, because we have to go in and check each of the values and see if there's any mistakes made. Some of the questions will ask you to do that. Some will be asking you to create a fill in missing parts, and you'll also need to create a table from scratch, kind of like we did. The rest should be pretty easy. Remember, though, to always use that order of operations. Whenever you are putting a number in. For example, if the number is 3x plus 1, or that's our rule, say, and I have to put in 2 into here, and I was going to rewrite that, I could write it as 3 times 2 plus 1. Remember that I have to do this first, because my multiplication must be done first. This would give me 6 plus 1, which is 7. Whereas if I did 3 times 2 plus 1, and I added first, which I should not do, it would give me 3 times 3, which is 9. And this is not correct. We must go in the order when we're working with our functions. And that is key. The rest should be pretty simple and self-explanatory. And good luck.